Traditional university course design often operates like a cottage industry. Faculty members design and structure subjects based on individual preferences and localized departmental habits. When an academic revises a specific module in isolation, it creates structural fractures. The subjects become disconnected, and the resulting degree program feels disjointed to the student moving through it. By 2015, Australian universities faced strict new reporting requirements under the Higher Education Standards Framework, along with heavy market competition from flexible online learning platforms. Charles Sturt University faced exactly this pressure. As one of Australia's largest providers of distance education, they had to respond to an increasingly crowded digital market. The university instituted an online by design mandate. To guarantee consistency and quality, every single course had to adhere to a strict online learning model. Delivering on that mandate required a specific pedagogical framework known as constructive alignment. This requires making deliberate, verifiable connections between intended outcomes, assessments, and teaching activities. But writing a policy document about constructive alignment does not guarantee its execution. To enforce it across an entire institution, pedagogical theory had to be encoded directly into software. A system built around software engineering forces the academic workflow out of isolated silos. It dictates the process, ensuring the design of a course happens as a unified, logical whole. The foundation of this system is backward design. Rather than drafting lectures or reading lists first, the process begins strictly with the terminal external standards the student must meet. This flowchart maps Charles Sturt University's course design process. Phase 1 starts with standards, synthesized into course learning outcomes. In Phase 2, assessments are built to test those outcomes. Phase 3 groups them into subjects. Red arrows show continuous feedback cycles correcting unaligned modules. In theory, this is a highly rigorous methodology. In practice, asking academic staff to manually cross-reference dozens of external standards against individual assessment rubrics demands massive cognitive load. Executing this via static PDFs, complex tracking spreadsheets, and manual templates guarantees errors. At an enterprise scale, manual constructive alignment inevitably collapses under its own weight. To solve the cognitive load problem, the university developed a bespoke enterprise software platform named CourseSpace. This CourseSpace menu turns the abstract flowchart into a structured digital environment. Phase 1 is mirrored at the top. Users must complete integrated standards and course learning outcomes first. Immediately below, it prompts assessment tasks. The top-to-bottom interface dictates the exact chronological sequence academics follow. The underlying architecture prevents users from skipping steps. A user cannot simply build an instructional module. They must explicitly link it to a previously approved assessed standard. For the academic, this removes the burden of tracking endless variables. The software guides them through the complex alignment mapping automatically. The menu architecture successfully translates pedagogical theory from an ideal concept into an inescapable daily practice. The theoretical blueprint was sound, yet when the first version of this software was released, faculty members actively avoided using it. Initially, the rigid waterfall development methodology isolated developers from staff, producing a culturally rejected application. To adapt, leadership implemented an agile framework with short continuous loops. Releasing incremental sprints allow developers to capture immediate faculty feedback and resolve friction points instantly. This shift elevated academics from passive end users into active co-developers. In prioritized workshops, faculty members dictated exactly what the interface needed to do to support their workflow. One direct result of this collaboration was the Connection Viewer. Faculty requested and developers built a visual mapping tool that instantly highlights gaps in the curriculum or areas where subjects are overassessed. Institutional software cannot simply be deployed. It requires continuous co-development with its actual users to survive the high cultural resistance typical of academia. Writing clean code and designing a smart interface only solves the technical problem. Changing the way a university operates requires a comprehensive operational strategy. System-wide adoption relied on a three-pillar architecture. First, top-down pressure. Leadership enforced the mandate. Second, bottom-up support. Instructional designers assisted faculty. Third, an inside-out focus on user experience ensured academics felt ownership over the tools. This combined approach yielded clear results. The institution successfully processed 53 distinct courses, mapping them precisely through this unified system. The objective of deploying software in this context is not administrative surveillance. The goal is the deliberate offloading of academic cognitive load. By allowing the software to carry the burden of mapping standards to assessments, educators are free to focus entirely on designing the student experience.